Hello students, today we'll be discussing about few sums based on inverse trigonometric function. So look at the first one. Here we have to find out the value of sine inverse of sine pi by 6. So see here, this pi by 6, this angle is falling under this range, that is from minus pi by 2 to pi by 2, which we know that we always have to check in PVV table. So the value of sine inverse of sine pi by x will be equal to pi by x only, because this value is falling under this range. Coming to the next sum, here see cosec inverse cosec 13 pi by 6 is equal to how much we have to find it out. Remember, we cannot write the value is equal to 13 pi by 6 because 13 pi by 6 will never fall on this range. So what we have to do, we have to use simple trigonometry, that is cosec inverse cosec. We can write 13 pi by 6 in this way, 2 pi plus pi by 6, and that will give you cosec inverse of cosec pi by 6. And then this pi by 6, this particular angle is falling under this particular range. So we can write the answer is equal to pi by 6. Now see, sum based on property 2, it is taken from ML Agarwal book, exercise 2.2. Check out this sum, 15 part 3. We have to find out the value of tan of cos inverse 8 by 17. Now remember, whenever you have tan outside and here you have some other trigonometrical function but not tan, so what is our objective? Here we have to bring, in place of cos inverse, we have to bring tan inverse. So what we are doing for that, we are using the triangle method, which I told you earlier also. So here cos inverse is 8 by 17. So we can always write, taking this angle as theta, taking this particular angle as theta, so we can always write like here the base will be 8 and the hypotenuse will be say 17, because we are taking cos inverse of 8 by 17 is equal to theta. So therefore cos theta is equal to 8 by 17. So 8 will become the base and the 17 will become the hypotenuse. You can always consider the common ratio along with that. So in that case, depending on the Pythagorean triplet, the perpendicular will become 50. So in this case, in place of cos inverse 8 by 17, we can write tan inverse of 15 by 8. And we know that range of tan inverse function is basically the real numbers. So we can write the answer will be 15 by 8. Coming to the next sum. See here we have to evaluate sine inverse sine 2 is equal to how much. So here see we have a different procedure to do this kind of sum. So we know that pi minus 2 belongs to in this range. So therefore sine of pi minus 2 will be becoming sine pi by 2. If you take sine inverse on both the sides, then it will become sine inverse of sine 2 is equal to sine inverse of sine pi minus 2. So the answer will be equal to pi minus 2. Never write the sine inverse sine 2 is equal to 2, because 2 is not falling under this range. Remember, so the procedure is this. The next sum is find the value of tan of cos inverse minus 2 by 7 minus pi by 2. So what we have to do for this type of sum? So in this case, see cos inverse of minus 2 by 7. By using the property, we can write tan of, in place of this particular thing, we can write it's pi minus cos inverse 2 by 7 and minus pi by 2 is outside. So if you open the bracket now, this pi and this is minus pi by 2 will give you pi by 2 and you will get minus cos inverse of 2 by 7. So pi by 2 minus cos inverse of 2 by 7 will give you sine inverse of 2 by 7. Now again, this sine inverse 2 by 7, we can use this triangle method. So again, we are considering this is theta. So this is 2 and hypotenuse is 7. So if we use hypotenuse square is equal to base square plus height square, that's the way we will get the base. And in that case, base will be 3 root 5. So this function sine inverse 2 by 7 we can always write it as tan inverse 2 divided by 3 by root 5. So the answer will be 2 divided by 3 root 5. Now this is a sum taken from exercise 2.2 This is sum number 4 part 2. You have to write the function in the simplest form. See, here we have tan inverse of cos minus sin x divided by cos x plus sin x. So see how we will be solving it. So we are just dividing the numerator and the denominator by cos x. So here we are getting tan inverse 1 minus tan x divided by 1 plus tan x. Now instead of this one, we can always write tan pi by 4. Then minus tan x is there. This one is as it is. Plus, we are multiplying tan x with 1. That means instead of 1, we can always write tan pi by 4. So it's tan pi by 4 into tan x. Why we are writing it in this way? To get a formula of tan a minus b. See, it's tan a minus tan b divided by 1 plus tan a tan b. So we can write it's tan a minus b. So our answer will be pi by 4 minus x. Next method that we'll be learning today, that is method of substitution. So there are few expressions where we have to solve. The sums is given in this form. So remember, this is the trick, like by which we can substitute the value of x and we can easily solve the expression given. See here, what is the values, what type of solutions, what type of hints are given. If in the sum we have a square plus x square, then we have to substitute the value of x either as a tan theta or as a cot theta depending on the sum given. So here you have to use your intelligence a bit, because depending on the sum, the assumption will differ. So you have to be very careful. So you have to do a lot of practice to be acquainted which substitution you have to do. Suppose for this a square minus x square, you have to substitute like this way. X square minus a square, you have to substitute in this way. Now for this you have to substitute in this way. Now for this you have to substitute in this way. Remember, these are the only few examples which I have given. Other than that also, you have to use your intelligence to substitute. Now just look at this sum. Here we have sine inverse x divided by root over of x square plus a square. So what we are doing, in place of x we are writing a tan theta. Why? Because see this expression and see this expression, both the same. So we can substitute either x's value with a tan theta or a cot theta. So I am substituting the x's value with a tan theta. So it will become sine inverse of a tan theta divided by root over of a square tan square theta plus 1. So we are writing, if you simplify it, you will get a tan theta divided by a sec theta. A will get cancelled, and from here you will be getting sine inverse of sine theta, which will give you theta. Now theta value is equal to what? It's x by a, and then tan will come this side, so it will become tan inverse of x by a. There is one more sum depending on this. Please look at that. This is taken from ML Agarwal book, exercise 2.2, question number 4, part 8. So here we have tan inverse of x divided by root over of a square minus x square. So we are using x's value is equal to a sine theta. Now in place of x we are using a sine theta divided by, it will become a square. If we take a square common, and then it will become a square bracket 1 minus sine square theta. In place of 1 minus sine square theta, we will get cos square theta. Under root over a square cos square theta will give you a cos theta, and numerator we have a sine theta. So a will get cancelled. So it's tan inverse tan theta, which will give you theta. And then finally, please substitute the value of theta. That is sine inverse of x by a. There is one more sum. See, here we have tan inverse of 2 root over x divided by 1 minus x. So what we are writing? We are writing root over x is equal to tan theta. So x will become tan square theta. So in place of root over x and in place of x, you can always substitute the value. Now it will become 2 tan theta divided by 1 minus tan square theta, which is giving you a formula of class 11, that is tan 2 theta. You have learned this formula in class 11. So tan inverse tan 2 theta is equal to 2 theta, which is equal to 2, and then substituting the value of theta, that is tan inverse of root over x. Now there is one more sum which is very important, that is prove that sine, that is question number 5 of ML Agarwal book, sine cot inverse cos tan inverse x is equal to root over of x square plus 1 divided by x square plus 2. Now see the solution. We always start doing it from innermost bracket and then we will come out accordingly. So here see, we have a tan inverse x here. outside we have cos. So instead of tan inverse x, we have to bring something related with cos inverse. So we are using the best method is called the triangle method. So what we are doing, we are taking tan inverse x is equal to theta. So x is equal to tan theta. So if this angle is theta, then perpendicular will be x and the base will be 1. And along with that, if we use the Pythagorean triplet, then we will get the hypotenuse as root over x square plus 1. So if we change tan inverse to cos inverse, then it will become cos inverse of 1 divided by root over of x square plus 1, because it's base by hypotenuse. So now the whole sum will become, now here we have a cos of cos inverse, so this term will be only there. So it will become sine of cot inverse 1 divided by root over of x square plus 1. Now again we will be using triangle method, because here we have a sine, here we have a cot, so we need a sine inverse here. So what we are doing, again we are using triangle method. We have taken this angle as alpha. So cot inverse 1 divided by x square plus 1 is equal to alpha we have considered. So cot alpha is equal to 1 divided by root over x square plus 1. So 1 will be the base and perpendicular will be root over x square plus 1. Now if we use Pythagoras theorem, we will get hypotenuse as x square plus 2. So here this will change as sine of sine inverse, then perpendicular by hypotenuse, that is root over x square plus 1 divided by x square plus 2, and which will give you the answer. So I hope you understood the sums. The assignments based on this particular exercise will be posted soon. Thank you.